Okay, so question 7, we want the gradients of these lines PQ, QR, RS, SP. We know the gradient between any 2 points is simply y2 take away y1 over x2 take away x1. And so if we were to take these points PQ, okay, the gradient of PQ, then we can do something like minus 1 take away 3 divided by minus 2 take away 6. If we tidy that up, that should give us minus 4 over minus 8, which is just a half. Is that okay? Right. The main thing to point out here is if I've started at minus 1 as my y2, and then I've chosen this as my y1, I need to make sure my x2 is going to be minus 2 here. And I don't swap the order of the x's around. I don't do 3 take away minus 2, because that will give me a minus sign. Some people end up making that mistake. If we do that for the other gradients, QR should be minus 1 over 3, RS equals a half, and SP equals minus 1 over 3. Alright, before I move on to part 2, is that okay? Any questions? Okay, no. Alright, part 2, what is an calculate the gradients. What is the name given to the quadrilateral PQRS? Any ideas? Parallelogram. So we've got 2 sides which are the same, but these 2 also have the same gradient. A rectangle would be perpendicular. All the sides will be perpendicular. So we know it's a 4-sided shape, so it has to be a quadrilateral. But what sort of quadrilateral? Parallelogram. Okay? So here we get a parallelogram. Okay, let's okay. What about calculate the length SR? Any suggestions about how we can do that? Sorry? Can't hear you. The distance formula. Okay, excellent. And that is based on what? Which theorem? Can somebody remind me? Pythagoras. Excellent. Okay, now that's just basically saying the change in y squared, okay, take plus the change in x squared square root will give us our SR. Now SR is going to be equal to, so you've got minus 2 squared plus 1 minus 9 all squared. Okay, square root. Has anyone worked that out? It should give you the square root of 80. Okay. Yeah, so you got 4 squared 16, 8 squared 64, 64. Yeah, and that should give you 80. Square root of 80. Alright. Part 4 is show the equation of SR is 2y equals x minus 5, and find the equation of the line L through Q perpendicular to RS. Right, quite a few things to do, so let's just break it down. Let's just work out the equation of the line SR. So the line SR, the formula for it is going to be y minus y1 equals m x minus x1. Write that down. You've got to pretend the examiner is a GCSE student. Okay, you can't assume he or she is psychic, has a PhD in maths, and knows you and knows what you're talking about. You've got to sort of make sure you explain it as much as you can. So y minus y1. Now, do we know a point that lies on this line SR? We know S and we know R. So we can use either one of them. I'm going to pick S because it's got smaller numbers, and the whole numbers 1 minus 2. So we'll just do y minus, so it's 1 minus 2 is a coordinate. So minus 2 equals m x minus 1. What's the gradient for m? For SR? It's a half, right? So we know that from here, this part here. Yeah, so you've got a half. And so if we were to tidy that up, we've got y plus a 2. Y plus 2 equals a half, x take away 1. Take the half to the other side. So you've got 2y plus 2 equals x take away 1. So now we've got rid of the fractions. You can expand that out, and that should give you 2y equals x take away 5. Is that okay? Alright, good. Any questions? Now let's go on to the next part of the question, which is find the equations of the line L through Q perpendicular to SR. So now we've got a new line on the scene, and it's called line L. So let's write down line L. We know it goes through Q. So again, I'm going to write down y minus y1 equals m x minus x1. The coordinate for Q is what? 6, 3. So let's just write that in there. So we've got 6, 3. And it's perpendicular to SR. We know the gradient of SR, so I'll just write down the gradient of SR equals a half. Therefore, perpendicular to SR is simply going to be minus 1 over half, which will give us minus 2. Capiche? Right, if we substitute that in, we will therefore get y minus 3 equals the gradient, which is minus 2, x minus x1, which is 3. Expand this out, and that should tidy up to give us y plus 2x equals 15. Yeah, so minus 2x, 6 times 3, 18, and then 6 times 2, 12, plus the 3 gives us the 15. Is that okay? Any questions? Alright, okay, so there you've got line L. And then it says, part 5, calculate the coordinate of the point T where line L meets SR. Okay, so now let me just put that in, label the question. We want to find the point T where L meets SR, correct? Right, line L is this equation here, and SR, the line SR is this equation here. Correct? And we're saying we want to find the point where they meet, and the point where they meet is called point T. That's what the question's asking. Right. Guess what it's going to be? Simultaneous equation. Sorry, yes, I didn't hear. Did you say? What did you say? So it will be a simultaneous equation. What we could do, there's various ways we can think about this. We can just rearrange this y. So y equals 15, take away 2x. So I've just taken this equation here. And we'll sub that into the equation above. So 2, instead of writing y, I'll write down 15 take away 2x, and that equals x take away 5. We can then expand this out, okay, and we should end up with x equals 7. Is that okay? Capiche? Alright. Finally, let's do calculate the area of the quadrilateral PQRS. Okay. Now, with the quadrilateral, let's just do part 6. Let's just have a little. There's no harm at times, and especially with these coordinate geometry questions, is to take out some sort of graph plotting software on your phone. Use GeoGebra or use Desmos, and just get a feel of where the coordinates lie. Okay. Now, a parallelogram, as I'm sure some of you have sort of recalled from GCSE, if I was to take off this triangle and put it on this side, we end up with a rectangle. Agree? Can you imagine that parallelogram? Yeah. So you take off one edge of it, so it's perpendicular. Okay. So I've got a perpendicular line here, and then that goes all the way down. And then this part, if I was to stick it on this side, we'll end up with a rectangle, essentially. And therefore, the area is just going to be base times height. So in our case, it will be SR times the height QT. We know SR, we've calculated that already, that's just the square root of 80. And then all we need to know is QT. So QT, so this point to this point would be Pythagoras again. So I'd write the formula, change of y squared plus the change of the x squared square root. So you've got 7 take away 6 squared plus 1 take away 3 squared square root, and that should tidy up to, let me just change, let me just get a thicker pen out here, and that should tidy up to give us a square root of 5. And so therefore the area is the square root of 80 times the square root of 5. If it's non-calculator and you want to tidy that up, this is simply 16 times 5, and therefore square root of 5 times 5 is just 5, square root of 16 is 4, and that should therefore give us 20. Is that okay?